50 wheels. That's the last one right there. And you know, getting a lot of response to my video about it. We talked about it for a long time. And you know, I get the guys with the CNCs coming back to me, oh, we could do this and we could do that. But the question is, the important question is, how much does that machine cost? Now, I have an engine lathe. I have a good one. I bought it brand new. Like I mentioned, it cost me $10,000 with all the tooling. I have a $3,000 set of collets for it. Got all the chucks, the Loris, the whole thing. But I use this for a lot of different things. I use this for many different things. I put one piece in here and turn it. What am I going to do? Set a program for doing that? It just doesn't make any economic sense for live steam work. And you could say that's a caveman way of thinking. Say whatever you want. I've had this machine since 1981, so that's what? 28 years. 28 years. So divide that by 10,000 into $10,000. That's what the machine cost me a year. I just did 50 wheels. Took me a little while. I did a few a night, 5, 10 a night. Went over here, cooked something, went up on a computer, worked on a computer, came back to some other work. I wasn't doing the wheels continuously. I don't need to. We used to have a turret lathe to do this work. We had a Warner Swayze turret lathe that we used, and it worked out pretty well. It cost me $1,200, and I hired someone to run it. Never had a machine experience before. In fact, Michael Ponticello, Giselle's brother, worked for me for quite a while, and he did nothing but wheels, ever. It's the only thing he ever did there. And he would come in, do the wheels, and go home. The tool worked fabulously. When I had the other tool, basically the same type of box tool, we did thousands and thousands of wheels with it. I'll take that tool now, put it on the side, I put the reamer, the drill, and everything in one of our bins over here, and it'll stay there until the next time I need it. Now I had made it so that, let me come closer. I made it so that there's a space right here. I can move these out. I can do a larger wheel. I don't plan on making a 33-inch or a 4 1/8-inch wheel. That is an 1.5 inch scale wheel. And if I turn out any kind of free trucks, I'm going to make them in 1.6, which is very close to this size. I'm just going to use one size wheel. And then a 50 or 40-inch wheel, a 5-inch wheel, which is, I had to move the tools out 1/4 inch. So I put a 1/4 inch gap, spacer between there, move the tools out, and set it up and run those wheels. You know, and we've done. You could yell CNC all you want over the years, but the old school for right now is worth it for me. I don't want to get involved in learning that. I don't have time. I think they're great. I think they're fabulous machines in the right venue, not for live steam. If you own the machine and you're doing other work with it, job shopping or whatever, you're paying for that machine, then great. There is not enough work in the live steam hobby, and I was in the business for 30 years. There is not enough work out there to warrant the cost of that. Right now, the Chaskey's going on about building a steamer for $10,000. And I'm assuming they're talking about 1.5 inch scale. Even with the CNC stuff, you couldn't do it. There's not enough people there that would want to spend that kind of money. Live steamers are notorious for not spending a lot of money. The bigger the engine, the less they want to spend. The smaller the engine, the more they'll spend. AccuCraft, little engine that big. Steam, great. $5,000. You get a great big engine, 1.5 inch scale. My K4 is worth $100,000. I'll never be able to get that for it. You just can't demand the money that the bigger engines are worth. If somebody could make a smaller one, maybe. But anyway, we're going to go on now, and we're going to do the flange, and I'm going to talk about that. I'm going to make a video all about my concept of how the flange should be shaped, and I'm going to make a tool to do that. We still do it on a lathe. I turn the wheels around the other way, and I do it in reverse, because when you do it forward, it's like two rollers coming together, like the roller ring roller of the old washing machine. They're trying to dig in. They're trying to dig in every time like this. Now, if they're going away from each other, the slightest amount of play in the bearings will just minimize by going upwards. The pressure is up, and it just falls away. And you can turn them out a lot faster. That chatter is disastrous. The other thing I should mention about chatter, I don't know if I mentioned this on the video, but my lathe here is a cast iron machine. It's heavy duty cast iron. The base is cast iron, so it's a solid machine. Now, anybody that knows anything about automobiles, cars, they have cast iron headers. The reason is that the cast iron absorbs some of the vibration and the sound. You want to get that rumbly sound, that West Coast Laker sound, the Laker pipes. You get metal pipes. The metal pipe resonate better. So that cast iron kind of absorbs the shock a little bit. And like a lathe, like a Jet, for example, the cheaper ones, they have a sheet metal base, 1/4 inch, 3/32, 3/16 sheet metal, and that's got to be a big vibration to me. So try to buy a lathe with a heavy duty base on a heavy cast iron if you can. If you want to do this kind of work, if you want to just do 8 wheels single point them, okay. But I wanted to make a few. I wanted to make a few wheels. So we're gonna move on now to the flange, and then after that, to look forward to, we're going to do the axles, and I'll show you what I do about the axles and pressing them on, and doing all the axles and so on in mass production. My mass production. Now there's maybe a CNC would be nice, you know, but I don't have it, so we'll do it manually, and I'll show you how to do that. Most of us out there actually have manual machines. We don't have CNC. I bet you there's only 5% of people out there that are watching this video that build live steam locomotives with CNC. So, we'll see you then on the next video.
So easy, a caveman can do it.